Well, on page 5, we have the following information. Question says, find the cumulative area that corresponds to the z-score of z value equals to 1.15. 1.15. So we look at the graph of standard normal distribution, this graph on the left-hand side. We find z equals to 1.15. So this is my z, 1.15. Then it has 1.1 and 0.005. So this number can be written as 1.1 plus 0.05. If you add these two decimal numbers, it actually equals to your z-score, which is 1.15. So to use the z table, first of all, since your z is positive, they're going to use a positive z table. First, find 1.1 on the first column. Then find 0.05 on the first row. First row. Then the intersection between them gives you the area, cumulative area on the left-hand side of 1.15. So this is your z table. 1.1 on the first column. This is 1.1. 0.05 on the first row. The intersection between these two is the cumulative area, which is almost 87% on the left-hand side. So it's the probability for this z-score. The probability of z-score being less than or equal to 1.15 is 0.87 or 87%. Well, to use your calculator, so here you have your calculator here. Click on second bars. Then you need to select not the first one. If you select normal PDF, it gives you the exact value. Since it says cumulative, you have to select the second one. So use the arrow, go to the second line, normal CDF, enter. The lower limit, leave your lower limit as it is. So leave your lower limit as it is. If it's not set to this number, you can use -1000. This is your lower limit on the left-hand side. For your upper limit, you're going to use 1.15, the number z. Enter, enter, enter. Another enter. As you can see, we get the exact same number using the table and the calculator. So the probability on the left-hand side is going to be 87%. Let's check the second example. The second example says, okay, now find the cumulative area that corresponds to z-score -0.24. So this is your z-score now. Since your z-score is negative, first of all, we cannot use the same table. We have to use a different table, negative z-scores. So you have negative 0.24, it is negative 0.2 and 0.04. Very well. On the first column, you find negative 0.2. On the first row, you find 0.04. The intersection between them is 41% or 0.4052. This is the probability that z is less than or equals to negative 0.24. Well, we can use a calculator to find the probability, cumulative probability, on the left-hand side of negative 0.24. So let us take a look at our calculator. So second bars, again, it's normal CDF cumulative, enter. Your lower limit, just leave it as it is, negative 0. I have negative 0.24, enter, 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 and here we go, the probability. Almost 41%. Well, so far we learned how to find the cumulative area on the left-hand side. So if you have a z value or x value, and here you have your value, and you want to find the cumulative area to the left-hand side, you either use your z table or you use your calculator. Now I expect you to ask, what if I want to find the area or the probability, cumulative probability on the right-hand side? What about this case? What about in between? So suppose I have my value here, and my goal is to find the probability on the right-hand side, cumulative area on the right-hand side. What if I want to find the area in between two values? Value 1 and value 2. Very well. So in each of these cases, they have to do a little bit of algebra. In this case, if you want to find the cumulative area on the right-hand side, you have to find the cumulative area on the left and subtract it from 100%. Remember that the area is 100% or 1 minus this little area on the left-hand side. It gives you the area on the right-hand side. So it's going to be 1 minus z table or your calculator. How about area in between two values? We have to find them separately, then do the subtraction. So use calculator or z table for value 2 minus, you have to do a little bit of algebra, z table or calculator for value 1. 1 minus first area minus the second area gives you the middle area. And area to the right. Well, let's take a look at some examples here. If the question says, find the area to the left-hand side of Z, suppose your Z is 1.23, you don't have to do any algebra. You just need to look at your Z table or use your calculator to find the area. So let me show you. So we're going to use our calculator. 1.23 is our Z value. Let's turn on the calculator. So second force, normal CDF, and my lower limit stays the same. My upper limit is 1.23. Enter, enter to get the area. As you can see, it's almost 89%. So area to the left is not that hard. How about area to the right-hand side? To find the area to the right-hand side of Z equals to 1.28, after finding 89%, you have to subtract that from 100% or the total area, which is 1. So you get almost 11%. So how do we use our calculator to directly find the area to the right-hand side of 1.23? So turn on your calculator. Second, VARS, and normal CDF. So now your lower limit is 1.23. And your upper limit, you can just set it as 1,000, 10,000, 1,000 is enough. Enter, enter, enter. So you get almost 11%. 11%. Well, let's take a look at another one. So if the question says, find the probability in between two numbers, 1.23 and negative 0.75, you have to find the probability on the left-hand side of 1.23, on the left-hand side of negative 0.75, and do the subtraction. The subtraction of the probabilities gives you the probability almost 66%. So the probability that your value is in between these two numbers is going to be 66%. Let us use our calculator to calculate these two probabilities. (1.23) and negative 0.75. So here, let's turn on this. Let me clear the whole thing. So here I'm having second VARS, normal CDF, enter. So first I'm going to calculate for 1.23. 1.23 is my upper limit. So since 1.23 is my upper limit, I'm going to use a negative 100 as the lower limit. Or you can say that, hey, why don't you directly use the lower limit that you have, which is negative 0.75? Why not? So your lower limit is given, your upper limit is 1.23. Enter, enter. 66%. Here we go. As you can see, it's exactly the same as the value that you have in this example, which is 66%. So next question says, find the area under the standard normal curve to the left side of z equals to negative 0.99. So your upper limit is given. Your lower limit, it can be negative 10, negative 100. So second was normal CDF, negative 10. I have negative 0.99. Enter, enter, enter. Almost 16%. Almost 16%. Well, next example, question says, find the area under the standard normal curve on the right side of 1.06 on the right side. So it means that your lower limit is z 1.06. So second verse, normal CDF. My lower limit is given, which is 1.06, and my upper limit, I'm going to use a positive number like 10. Enter, enter, enter. Almost 14%. Well, another question for you. Find the area under the standard normal curve between these two z-scores. 1.25 is your upper limit and negative 1.5 is your lower limit. Let's take a look at our calculator. So second verse, normal CDF, your lower limit is negative 1.5, so negative 1.5, and your upper limit is 1.25. 1.25. Enter, enter, enter. And you get 83%. 83%. So in this project, we're going to deal with normal distribution. The students are instructed to collect data and use the data to find the mean and standard deviation to construct a bell curve to display the data. Students will also answer questions about standard deviation, z-scores, and variance. So, objectives: the students will be able to organize and collect data about the research topic, sketch the graphs of the data using the bell curve, use the graphing calculator to assess finding the mean and standard deviation, and finally analyzing the data and make conclusions. So you're actually doing a project like a pro statistician. Well, let us move on to the next page. The goal of this activity is to be able to take data and correctly use the data to find the mean and the standard deviation to construct bell curve, as well as answer questions involving standard deviation, z-scores, and or variance. This will allow students to use higher level thinking skills to create their own example of possible data that could fit the normal distribution. Okay. So these are the assumptions of prior knowledge. You need to know about z-score. You need to know about the center of the data. You need to know about very well variables and how to use your graphing calculator. You can either use your online emulator, or if you have TI-83, TI-84, those are absolutely fine as well. Okay, perfect. We are on page 3. In this activity, you'll investigate the relationship between real-world data and the normal distribution. Each group will collect data from at least 15 different resources in order to create at least 3 different graphs. The students will be divided into groups of 2 or 3 persons in each group. Below you will find a detailed outline of what is specifically required from you. The normal distribution activity. So we're going to collect data about people's height or about people's shoe sizes. So you can come up with these 2 ideas, or if you have any idea related to your own major, I encourage you to use that as the beginning question. Remember, in statistics, we always start by asking a question. Then I expect you to start gathering the data. You can use online resources. You can create surveys, but make sure it's not a biased sample. So after collecting the data, you can use data collection worksheet on page 7. And this is an example for you. Well, now after collecting the data, you need to graph those data. You need to find the mean, standard deviation for your data. As I mentioned, there is a sample for you. And don't forget to answer these questions. And here there is a rubric for you. You can follow the rubric, it's very helpful. Plot the first bell curve. Answer the following questions. So as you can see, I'm not really actually interested in your actual data. I want you to use your z-scores to answer these questions. The second one and the third one. Well, here's a sample for you. Students collect the data, answer the questions, graph the data. The second one and the third one, and their answers to the questions.